Okay, so now we are going to work on a real life example, and this is the credit card fraud. Now we all know that nowadays lots of frauds are happening, particularly in the financial segment and particularly on the credit card. So let's do this exercise to understand as to how we can find out whether the fraud has been taken or not, or what is the possibility of a fraud, etc., etc. So let's clear the output here, and then we'll start working on that. So it got cleared now, and now the credit card fraud detection, right? Then the credit card fraud is one of the biggest issues faced by the banks and the user. The amount of money involved in this is generally enormous. So let's see what are the challenges faced by such service providers, and what are the strategies that we have to adopt to tackle this gargantuan problem, and also why is it that you get harassed by frequently via these messages, right? So these are some of the important experiences that people shared. Now the third is that how can a credit card fraud happen? What are the reasons? Some of the most common ways it may happen are firstly, the most ostensibly, when your credit card details are overseen by somebody. Then when your card is lost or stolen and the person possessing it knows how to get things done. Fake phone calls convincing you to share the details. And lastly, most improbably, a high level hacking of the bank account details. So that also is a possibility. So let us run that. These are the reasons for that. Then main challenges involved in credit card fraud detection are enormous data is processing every day, and the model built must be fast enough to respond to the scam in time. Imbalanced data, that is most of the transactions, 99.8% are not fraudulent, which makes it really hard for detecting the fraudulent ones. Data availability, as the data is mostly private. Misclassified data can be another major issue, as not every fraudulent transaction is caught and reported. And last but not the least is that adaptive techniques used against the model by the scammers. So these are some of the things which I think is the in the background, the reason why it is happening, and why it becomes difficult to detect the fraud. Now, how to tackle these challenges? The model used must be simple and fast enough to detect the anomaly and classify it as a fraudulent transaction as quickly as possible. Imbalance can be dealt with by properly using some methods. What is imbalance? Imbalance means that if they, just mentioned that 98% of the data, or 98.5% or 9% data is correct, or is not having any problem, but the balance 1% or 1 point something percent is the fraudulent. So the data is not balanced. That means if it is 60-40 or 70-65-70-30, something of that sort, then it is understandable. But if it is just 1% possibility, then the data is not balanced. But then you can't do anything, but we have to find the way out as to how we can handle this thing. Then a more trustworthy source must be taken, which double check the data, at least for training the model. Then we can make the model simple and interpretable, so that when the scammer adapt to it, with just some tweaks, we can have a new model up and running to deploy that. So these are some of the kind of challenges that we have. So we can run this also. Now we are going to deal with the imbalance. We just discussed about it. So we will see the data received is highly imbalanced. That is, only 17% of the total credit card transaction is fraudulent. Now you can imagine that is very small percentage. Well, a class imbalance is a very common problem in the real life and needs to be handled before applying to any algorithm. So we can run this also. Then there are 3 common ways to deal with the imbalance of data. Undersampling, one-side sampling by Cubat and Matwins, ICML 99, this is a methodology used for this. Then oversampling, smooth synthetic minority oversampling technique, and combining the above two. So these are some of the techniques which are used. We should know about them, but yes, the people who are involved in this, definitely they should know about it. Then coding, of course, that is important. How to go for it? That is import all the libraries that we need, like in NumPy, Matplotlib, and Pandas, Seaborn, etc. So these are the codes which you are familiar with. So we can import all of them as per our requirement, and then we will use them wherever it is required. We should also have the data set that we are going to use, and here the data set is in creditcard.csv, which is in this particular folder, and we are importing it to store it in this data, that is the data frame, and it is a CSV file. So CSV file, and we are using this. It is of course Panda, and we are reading it and then storing it in here in the data frame, right? This is the data frame for that, right? And then we will be using data only for further processing. So we can import this also, load this data. This data will be loaded now and will be available for our working. Now once this gets loaded, then we are going to check for the top 5 rows. That is with the help of this code. That is where you are going to get it, like time, 5 rows and 31 columns. These are the columns, V1, V2 like that, and up to V30, V28 in amount and in class, right? So this is the way you can get that. Then due to some confidentiality issues, the original features are replaced with V1, V2. Okay, normally we cannot give these are confidential data, so which are the result of the PCA transformation applied into the original ones, and the only features which we have been transformed with PCA are time and amount. Features class in the response variable, and it takes value 1 in the case of fraud and 0 otherwise, right? So this is how we can distinguish the two. So we can run this also. Then time is number of seconds elapsed between this transaction and the first transaction. That's also important in this data set. Then amount, this is the transaction amount. That also we can run. Then class 1 for fraudulent transaction and 0 otherwise. That also can be run. Then know the numbers. You can choose to uncomment the second time if you want to work on a smaller data set first, and then everything is working fine. Comment it once again and run all the cells. So you can do that also. Then now we are going to check the shape of the data, that is how many rows and columns are there. We have 284,807 number of rows, so data is quite huge, and 31 columns, right? So that also, because it is always you need good amount of data so that you can, and moreover if you want to detect it, because as you said that the percentage is very small of the fraud, so definitely the amount of data that you have to work on the entire data set. Then we are going to have the description of the data. With the help of this, you are going to get the statistical information about the data, like count, mean, standard deviation, etc., etc. Then some more information about the data, that is info that you got about each and every variable that you have, V1, V2 up to V28, and these are all float 64. Then you are going, now we will be using visualizing all the features from the data set. So we can do that also with the help of this. Here we are using the data, features is equal to data, iLock, we are selecting the data with the help of this, columns, and then plot figures. Fixed size is 1228 into 4, and then GS, that is grid space. Grid spec is equal to 28,1 for IC in enumerate data, that is features, and then axis is PLT subplot GSI, and then SNS displot. We are going to have the displot, right, for this, and with 50 bins, and then the displot for data class, and here again we are using the 50 bins, right? So we are having this distribution plot here, and then on x-axis we are having this, that is AX is equal, set is equal to X label, and set title as histogram of features. And when we go for the plotting the graph, you can see that the plot, the graph will get created, and that will tell us about what is the pattern of the data, because depending on the criteria that we have mentioned in this particular code, you will see that you are going to get a good graph, that is distribution plot, right? So this distribution plot will tell you that how the data has been distributed over the whatever say total amount of data that we have. This is taking some time because the data is quite large, and this is the way you are going to get this. And moreover, there are 28 features, that is V1, V2 up to V28. So all of them have created a different kind of a histogram, right? And then a distribution, that also you can see. So both is a combination of the two. So histogram feature V1, similarly you get the V2, right? You can see that V2, and then we are getting V3, like that you are getting for every individual variable and different type of graph that you are getting. So this tells us the pattern in which this is going to be, we can infer from this particular graph. That is why the visualization is very, very helpful. And these types of graphs, with your knowledge of that particular domain, you can definitely make very good inferences from this. This is and you can see that all these variables from V1 to V28, all of them have been displayed here with different kind of a graph, right? These are all distributed, because you will see that this blue line that you are seeing, this tells us the distribution pattern of this, right? And you will find it in every graph you will see that, right? And this is a combination of the two, distribution with histogram is also there. Now the type of graph, then let's separate the fraudulent cases from the authentic ones and compare their accuracies. So we can do that also. Now we are going to determine the number of fraud cases in this data set. So fraud data is equal to data, then class is equal to 1, and data class is equal to 0. So this is the way we are going to distinguish, which you already decided the criteria. And outlier fraction, len fraud, and oblique float, len valid. Now this again is a criteria on the basis of which we are deciding whether it is outlier or is there or not. Then print outlier fraction, print fraud cases, and print valid transactions. So with this code you are going to get both these fraud cases and valid transactions, right? So we can run this and we are going to get the number, that is fraud cases are 492 and valid transactions are 2,84,340. You can imagine that against 2,84,000 their fraud cases are there, and that is the real case, because that is what happens. Not that every case is having some kind of a fraud, but then that is what it is. And you can also see that these figures are very much looks to be quite impressive and quite accurate. Now fraud, there is only 0.7 answer. This also you can see that 0017, that means about 17% of the fraudulent transactions out of all the transactions. The data is highly imbalanced. Let's first apply our model without balancing it, and if we don't get a good accuracy, then we can find a way to balance it, right? So these are some of the things that as a developer or as an analyst you must do, right? Then we are writing this code for printing amount details of fraudulent transaction and fraud amount described. So we can write this code to get this, take it count this much, 492, mean is this much, standard deviation. These are again for our information, and we must try and understand what are we can derive meaning from this, right? So like this you can also print details of valid transaction, valid amount is equal to this, that also is going to helpful, like this, right? And now as we can clearly notice from this, the average money transaction for the fraudulent ones are more. This makes this problem critical to deal with. Now correlation matrix graphically gives us an idea of how features correlate with each other and can help us predict what are the features that are most relevant for the prediction, right? So this again we can run it. Now correlation matrix we can get with the help of this code, that is correlation matrix is equal to data and then correlation, figure, plot figure, fixed size 12,9, SNS heat map we are going to generate with because correlation you can get very good information from heat map. Varimax is equal to 0.8, square is true, and PLT show. So then we are going to show this kind of a graph which is getting generated with the help of this code. So this is the heat map which gets generated, you can see, and all these variables V1 to V28, all of them are there along with the amount and class. So all that tells us that what is the pattern of the correlation, right? So this can be seen here. Then in the heat map we can clearly see that most of the features do not correlate to other features, but there are some features that either has a positive or a negative correlation with each other. For example, V2 and V5 are highly negatively correlated with the feature called amount, and we also see some correlation with V2, V20 and amount. This gives us a deeper understanding of the data available to us. With that out of the way, let's proceed with dividing the data values into features and targets. So we can, this again is a remark, so nothing will happen. But now in this code, that is dividing the x and y from the data set, now we are going to divide it. So we can drop some, like class we don't need, then y x data is equal to drop class, x is equal to 1, then y data class again from there also we can do, then print x shape, print y shape, and getting just the values of the for the sake of processing. It's numpy array with an amount, and x data x values and y data y values. So we can run this and we are getting a shape of this, that is 2,84,807 and 30 columns, and this is again 2,84,807, and of course the columns are same, so it's not printed. Then using scikit-learn to split the data, now we are going to split the data into training and testing. So we can do that, and now with this code we can do that, that is from sklearn model selection import train test split, then split the data into this, and then this is the way this is going. This code will help us divide this or split this, and then the test size is going to be 20%, that is 0.2, and random state is going to be 42. So this is how we can split our total data into two different, that is training set and testing set. Run it and you can see that it will do the job for us, that is it will split the total data. Now we are going to build the isolation forest model. That is, isolation forest is generally used for anomaly detection. Contamination is the amount of impurity is the data set. With the help of this isolation forest model, what we are doing is that we are trying to isolate the anomalies or the dirty data or the impurity in that, whatever you may call it. Then we are going to build another model classifier which is known as isolation forest. Now this isolation forest can be, the code for that is from sklearn ensemble import isolation forest, which is required, IFC, that is isolation forest, and then that is equal, this of course is a variable that we have defined, and this is the code that we have written for this. Maximum 5 samples and length is xtrain. Contamination outlier is equal to fraction, random state is 1. Now IFC fit, then we have to fit it also, the xtrain, and scores prediction is equal to IFC decision for function xtrain, right? So whatever we have done in the xtraining, all that we are considering, and now we are going to do the y prediction, that is y pred is equal to IFC predict x test. So with the help of this code we are going to do the calculation, and we are storing the y pred into this particular variable, that is y pred. So with this, working on, after this gets completed, then we are going to build and evaluate the matrix on the test set also, because right now it is we have worked on the training set. We have split it for the data set first, then we had created that 80% into training and 20% for the testing part that we have done, and now we are doing this. With this code we have done the ypred calculation, which is getting stored also in ypred. So once this gets completed, then we will move further on to building and evaluation of the matrix. right? So because the process is quite long, and then of course the data is also quite voluminous, so that is why it may take some time. So let's wait for that time till it gets completed, so that we then go to the next step and start working on that. So that is why it is very important that your machine should be very, very powerful, otherwise it takes time. In fact, you must always be very particular about it, and do not use or open so many windows also. No other extra things should be there in order to have your speedy working. So just wait for some time, and then I think it will get completed, and then we can move further on to this. See, the amount of data that we have is about 2,84,000, so almost 3 lakh transactions, which is fairly, so for that, and then your logic, then your other things that are happening, so all that takes time. But yes, this is very, very useful algorithm for detecting these kinds of frauds which are happening, and particularly for the financial institutions, whether it is bank or any NBFCs, non-banking financial companies, anybody who's involved in financing, if they are lending or doing anything, then they must be very, very particular about it, because the number of fraudulent transactions are not many. They are just 1%, 2%, 3%, like that. Maximum maybe 15-20%. But then the volume of the amount that is involved in that is phenomenal. Now it gets completed, so we will move forward onto this. So building an evaluation matrix, let's see how to evaluate the model and print the results. We will be calculating the accuracy, precision, recall, F1 score, and the Matthews correlation coefficient. So all this we are going to do now with the help of this code. Now this code is that reshape the prediction values of 0 and for valid, 1, 0 for valid, and 1 for fraud, right? So that is how we can say that 0 for valid and 1 for fraud. Ypred is equal to 1, and ypred is equal to -1, that is equal to 1. So n, a number of errors, ypred is not equal to ytest, and sum. So this is how the code, which again is, and then when we run it, then you are, of course, it has transformed everything into these variables which we have created here, ypred, etc. Now we are going to visualize the confusion matrix for this. So for that we have written the code like, printing the confusion matrix from sklearn, import confusion matrix, labels normal, fraud, confusion matrix equal to confusion matrix, ytest, ypred, plt figure, fixed size 12 by 12, then SNS heat map we are going to create, confusion matrix, x tick labels is equal to labels, and then y tick labels is annotation is also going to be true, formatting is going to be D, and then plot title is going to be confusion matrix, y label is true class, x label is predicted class, and then we are going to plot the heat map. So once we do that, you can see that this confusion matrix is created for you, and here you are seeing that the true class and the normal, and all such things are now available to you in this heat map. Normal, predicted class, fraud. So many fraud and so many predicted, all of them are available to you in this. So that is how this heat map is very useful. Now let's see how to evaluate the model and print the results. We will be calculating the accuracy, precision, recall, F1 score and Matthew correlation coefficient also. So we can run this. Of course, nothing is going to happen, but the evaluation of the model, printing every score of the classifier and scoring of the things. Now from sklearn, import accuracy score, import precision score, import recall score, import, all these things are available as a library, small library, and we need not go into details of that, because we should know that yes, we need and we must import it. Import F1 score and import Matthew correlation coefficient. So then n outliers is equal to length of fraud, how many number of frauds are there, right? And then print. The model used is format isolation forest, that is what we have done earlier also. Then accuracy score y-test y-pred, accuracy is whatever is there, format accuracy, precision score y-test y-pred, then precision is format precision, then recall score y-test y-pred, recall is format recall, and then F1 score also y-test y-pred, and then F1 score is going to be also printed. And then MCC, that is Matthews correlation coefficient, y-test and y-pred, because we wanted that Matthews correlation coefficient should also be printed. So print Matthews correlation coefficient with this command, that will also get printed. So we can run this, and then you can see that all those things we wanted are now available. So model used is isolation forest, that is also already we have mentioned. Then accuracy is 0.9978, which is fairly good, very good in fact. Precision is 0.375, recall is 0.3367, F1 score is 0.3548, and Matthew correlation coefficient is again 0.354, right? So whatever in this particular code has done, these are the results of that, right? So as we can clearly see, this model is not doing as great as expected. So let's build some other model to get a better result, right? So we can, that is why, you have to be always prepared, and do not think that, only one time that you have, whatever you have done, that is the final. You can keep on doing till you are satisfied, till the result that you get are satisfactory. You can keep on doing it. That is a very big advantage in this. Now we are going to have the random forest model, right? So let us build a random forest to increase the performance of the detector. So we can use a decision tree model, but as we know, random forest is like an array of decision tree. Then then why to even bother trying and failing? So you can think random forest to the ensembling applied to the decision tree. Here is a nice and easy explanation for random forest. So we can go for that. This is again for our understanding. Then next is that building the random forest classifier. Random forest, from sklearn we are importing the random forest classifier, and RFC, that is the variable in which we are going to have this random forest classifier. And then we are going to fit the model, that is rfc.fit xtrain ytrain, and then we are going to have the ypred RFC prediction xtest. So this we are going to do with the help of this code that we have just executed, right? So we are in this, you will see that we have imported the random forest classifier, and then we have also done the working of random forest classifier, and we have also tried and fitted the model using the xtrain and ytrain data, right? And then we are going to have the calculation which is stored in ypred. This is also done. So this is random forest algorithm that we have used here. So again we have to wait till it gets completed, again because of the volume of data that we have, it is taking time. Once it gets completed, then they will definitely move on and go further into this, which is almost complete now. We will then be building some evaluation matrix on our test set, so that we can definitely go for the final round. Wherever there are such calculations, you have to fit the model or build the model or do some such thing, then definitely it takes time, and also depends on the volume of data. That is definitely a very big criteria, very important criteria. You have no other option but to wait. Let's hope that it gets completed soon now. Just wait for some more time. I think we have no other option but to wait. So let's wait for some more time. Let it complete, and then we will move forward. I think it is taking quite a time. Good. it is taking some time, but we can't do anything. We have to simply wait for this. Random forest is a big, algorithm, and it definitely takes some time. It is working, but it is definitely taking time. That is why real life data and learning data or test data is always different. There the amount of data or the volume data is not that much, but in the real life the actual data is definitely quite voluminous. So now I think it is done. So let's move forward now and see that what next is to be done. So let's see how to evaluate the model and print the results. We will be calculating the accuracy, precision, recall, F1 score and the Matthews correlation coefficient. So we can run this. Nothing is going to happen here. Now we are going to use this code evaluating the classifier, because that needs to be done. Printing every score of the classifier, scoring in all these things, and for that we need to have the matrix. So from sklearn matrix, import classification report, accuracy score, precision score, recall score and F1 score, and then the Matthews correlation coefficient. So all these things need to be imported from this library. Then we are going to have the from sklearn import confusion matrix also. Outliers, from n outliers is equal to length fraud, that we get from this. Then number of errors, ypred is equal to ytest sum. Then the print model test is a random forest classifier, and then the accuracy score on this ytest and ypred. Then print the accuracy is format ACC, that is what is the accuracy and what is the format of that. Then precision score, ytest and ypred. Then precision score is format, what is the score format for that. Then recall score. So all of them, whatever we have done, the recall is that, for format of this is that, and then F1 score also. And then we are going to have the MCC, that is Matthews correlation coefficient also, and for that the format is MCC, and Matthews correlation coefficient is going to be there as the heading for that. So we can run this, and you can see that all of them are now going to be available as a result. So the model used is random forest classifier, accuracy is 0.99. Earlier also we got about 99%, precision is 0.97, recall is 0.78, F1 score is 0.87, and MCC, that is Matthews correlation coefficient, is 0.87, right? So this is how you can get the results from different algorithm, right? Now we are going to visualize the confusion matrix as well, right? So printing the confusion matrix labels: normal fraud, confusion matrix, ytest, ypred, and then the PLT figure, fixed size is 12 by 12, and then heat map, confusion matrix, x tick labels is equal to labels, and y tick label is equal to labels, annotation is true, and format is going to be true, D. And then we are having title as confusion matrix, y label is true class, x label is predicted class, and we are going to show the plot. So once we run this, we are going to have this, as we have seen earlier also, almost in the similar way we are getting this also. So you can see a good confusion matrix is got created. Now so the conclusion is that let's see how many goals have we achieved. The model is fast, it is definitely simple, and most importantly easily interpretable, shown in the decision tree diagram. The privacy of the user is still intact, as the data used had its dimensionality reduced in this from the beginning itself, and well, we still have not managed to deal with the unbalancing of data, but I think we have done very good job without it. So we can see that even we were not able to do anything for the that imbalance of the data set, but then since we have done it in two different algorithms, we have been able to get a better idea as to what should be the acceptable score for this, which we have seen in these two cases. So that is how the two algorithms can be used for the purpose of this credit card fraud detection. We have seen that it has taken some time because of the various factors that we discussed, but then that is how it is. But this is the good algorithm that we can use for the purpose of credit card fraud detection. Thank you.